Hi, Denise. All right. Yeah. All right. Oops, no, screen two. Okay. Plus, one of the other things I did is I just got two monitors. So I'm like learning how to use the two monitors and all of that good stuff. Okay. So I think I don't know if what I can do, if I can write on this or not. If I can write on this or not. Okay. So again, there's going to be a nice little learning curve here. Oh, now I can. Okay, good. There we go. Okay. So let's see. Oh, and this doesn't have the timings on it either. So this one goes over 3.01, which yeah, that's what we were just talking about. Okay. I'm with it. I know what's going on. So we have the first thing that this introduces us to is, well, not introduces, but it's really review on rational numbers. So the important thing to know is it's fractions versus no fractions. So anything that can be written as a fraction. And some people get confused about repeating decimals. Repeating decimals can actually be written as fractions. There's a little rule about that where it's over, I'm going to make this black. There we go. It's over nines. So like this would be 23. Oh, nope, that's not going to do. Let's try this. 23, that's better. Over 99 because there's two repeating numbers. I'm going to move this down and see if I can get it. I'm awesome. Let's try. There we go. Okay. And so this would be over 99. So like one repeating number would be something over 9. And then I'm going to have you turn your camera off though, because it's recording the screen. And then I don't want it to, because I post these afterwards. So I don't want we don't want students on there. Like, I'll ask for questions later. Like if you have a question, you can let me know and then I'll pause it so you won't be on the thing. Okay. So this is rational, even though it repeats, this is rational because it can be written as a fraction. So here's the part where some people get confused because a lot of times it'll ask like, give an example of a irrational number. And so a lot of times students will be like, 2.79, and they'll just like list off a bunch of numbers, but that's a lot of work. There's pi, which is the famous one, but any square root of a non-perfect square. So like the square root of 2, the square root of 5, anything that's not a perfect square, that's an irrational number. So if someone asks you, well, okay, well, give me an example of an irrational number, what does that mean? You can say, well, it can't be written as a fraction like the square root of 2 or the square root of 5. And that's something that some people have kind of come up against with a challenge in this unit. Okay. Actually, you know what I'm going to do? I'm going to go back and I'm going to pause this. Let me see if pause. There we go. All right, so then we have the review of the exponent rules, which most people know. This is just something you really have to brush up on because like at this point, if you don't know these really, really well, everything's going to be a lot harder. So if you haven't looked at this for a while, this is really where you're going to want to kind of spend some time remembering things. So there's multiply and divide. If we're multiplying, we add the exponents, dividing, subtract. Which makes sense because multiplication is repeated addition and dividing is repeated subtraction. If you're doing a power to a power, so it says exponent outside parentheses. So that means if I have like 2 to the 4th, no, that's not what I mean. Sorry. This is not, I have a stylus and it must be because my new computer is like super sensitive with the response, but it's like, I normally have better handwriting than this. So I feel really weird. All right. So let's say we have 2 and then that's in parentheses. Oh no, I was right. you'll get used to my weird like stream of consciousness. I think out loud a lot. All right, so I was right. So 2 to the 4th raised to another power. So if the exponent is outside parentheses, this is a power to a power. So this is the power to a power rule. And so then what we would do is distribute the exponents or we multiply them. And that is important because that includes fractions. So here we only have one term, and so that's easy. That becomes 2 to the 4 times 3. Oh my gosh, this is so annoying. I'm going to have to get much more used to this, which is 12. So this becomes 2 to the 12th. And that's not too difficult for people to remember. But where people start getting really confused is when it starts having things like this. So let's say we have this. Well, then people start freaking out because they're like, oh my gosh, there's so many numbers. So this is when it turns into the distributive property. So this really means exponents just give us the number of the bases. So this means now that really this whole thing is the base. This whole thing is raised to the second power. So we have 2 of them, a squared b cubed c times a squared b cubed c. And so because of that, we can distribute this exponent to each component. So we have, oh, didn't mean to do that in green. There you go. So we have a squared, we have b cubed, squared, and we have c squared. So this is distributing that exponent. And then we use the exponent multiplication rule, and this becomes 2 times 2, 3, not multiplication, the power rule, 3 times 2, and then just 2. So we get a to the 4th, b to the 6th, and c squared. So this is why, excuse me, this is why those rules are so important, because if you don't remember what they are, it becomes very difficult to know where to start. And if you can't remember where to start, then that's really where the problems start to happen, because then people feel like, well, I don't know what's going on and I can't do the whole problem. So I'm just going to write stuff down. And then we have that's the operations rule, like not operations, but calculation rule. Multiply means add, divide means subtract, and power to a power means multiply. But then we have the identity rules, which is anything to the 0 power is 1, anything to the first power is itself. And so people don't tend to have a problem with that. Oops, hang on, admit, there we go. Yay, we have somebody else. Welcome. So this is also one of the rules that people get really confused about is negative exponents. So if this is super, 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 super important, if you don't want to be confused later on. And you've probably, most people have probably had this. If you haven't, then that's okay. But negative exponents, they mean divide. They are not negative numbers. They are simply a shorthand way for us, like an abbreviation, to write a fraction. Okay, and we get more into that later. And so this becomes a reciprocal. If you have a negative exponent just in a normal number, then that becomes a denominator. And if you have a negative exponent in the denominator, then it becomes the numerator. So you have these reciprocals. And then let's say you get a bunch of different things that you have to do. You've got powers to powers, you've got negative exponents everywhere. There's just exponents everywhere. It's still the order of operations. So you do parentheses, which is grouping. So anything in the parentheses that you can do, you would do. Apply the multiplication rule if you have the same bases, etc. Then you would do the exponents, which would be the power to a power. And then you would go from there. So when in doubt, apply the order of operations. Okay. All right. So Inverse operations is also really helpful here. I kind of mentioned it on the other one with repeated operations, but adding and subtracting are inverse, multiplying and dividing are inverse, and then we learn a new one. So these four are not the only ones. We learn a new one this year, which is exponents and roots. So you know that exponents exist, you know that square roots exist, cube roots, but they are actually inverses. And that's important for the rational exponent property, which is what has been confusing people. So we're all lazy. I'm lazy. Everybody's lazy. Human beings are lazy. We always go for the path of least resistance. There's no shame in being lazy as long as it doesn't cost you anything. If it starts causing problems, then that's not so good. But most people are just lazy because we only have so much time in a day. So there are certain things in math that we don't write. They're called the understood. Okay? So one thing that exists that nobody writes are decimals and zeros after whole numbers. I don't know why this says after it. It should say after whole numbers. Let me fix that. After whole numbers. See, it's getting better. I'm learning with my new setup here. Nobody writes those. It would take forever. Like, when would you stop? Nobody writes those, except in money, but not quite the same thing. Then we have the coefficient of 1. And when you first learned about coefficients, you might have actually done this. And I usually tell my students in like 6th and 7th grade that when they're first learning about variables, to write the coefficient of 1 so that they remember that it really represents one something. But nobody writes them once you know that that's what it means. We don't go around writing 1x, 1y, 1p, 1q, 1r. So that would take extra time. So nobody writes that. We just write the variable unless it's something other than 1. And then we put 2, 3, 4, 5, whatever. So nobody writes that. And then up until now, when you start learning about exponents and roots, no, you don't realize that there are actually exponents on all numbers because no one writes them. But every number technically has an exponent of 1. It's there. We just don't use it. We don't talk about it. We don't write it because you don't learn about exponents until you're in middle school. So, like if I tried to talk to my 8-year-old about it, he'd be like, what? So we just don't talk about it, but they're there, but nobody writes them. And this is important for the rational exponent rule that we're going to get to in just a minute. The same thing is true with square roots. Anytime you just see a radical sign, which remember, that's called the radical sign. Mine not drawn very well. There's a reason I don't teach art. There we go. So this radical sign can be to any like number, which we call the index. But usually when we see it, we just see this with a random number under it, right? Oh, look, that was the example I gave here. Oh, so it's not me, it's this. This is like weird. It's hard to write. Okay, that's better. Sorry, I have like random circles all over my page. So, but every time you see this, normally, that actually has a 2. This is the understood 2. It's the only one that isn't an understood 1 or 0. So you have zeros and ones, but this is an understood 2. But nobody writes that because most of the time, you're only interested in the square root. It's not until you get to higher levels of math that you even realize you can take cube roots or 4th roots or 5th roots or 6th roots. So again, there's no need to write that 2 when you learn about radical signs because you don't do anything else with them for such a long time. But that's there. And that's super, super, super important. Every number has an understood exponent of 1, and every radical that doesn't have some other number has an understood index of 2. But that seems weird because we don't ever talk about it until now. But if we wrote those understood numbers, this is what it would look like. because all numbers have that understood 1 and all radicals have an understood 2, unless there's something else there. And so it would look like this. And so this would tell us I want the square root of 9 to the first power, which is just the square root of 9. Or I want the square root of 25 to the first power, which is just the square root of 25, which is 5. So that would take so much time and would also confuse people who don't know that there are other things to do with it. So you just didn't know it, but now you do. You do know it. And so you should feel like, oh, I know so many more things because I learned it. So here's the thing. This is the rational exponent concept. Anything in math, we can write it an infinite number of ways. We can split stuff up with addition, subtraction, division, multiplication, exponents, square roots, fractions, decimals. We can write stuff almost any way we want. We usually just choose the easiest because we're lazy. Or the better word would probably be busy. We're busy. That's why we don't have time to do it any other way. So here's what this means. I can write the number 5 the way we normally write the number 5, which is the number 5. I could write the number 5 this way, radical 25. That still has a value of 5. That's still 5, but it takes a lot longer. And someone who's like 4 wouldn't recognize it. I can also write the understood components. So I could write the index of 2, radical 25 to the first power. This is still the number 5. I just have a lot with it, which again, for people who don't know what that is, would be very confusing and kind of scary, not going to lie. So we don't write it like that. And now the rational exponent rule is, look, what if I don't want to even write the radical sign? Because gosh darn it, that radical sign takes so long to write. I think a straight line is just so much easier. I know, let's turn it into a fraction. Because, I mean, I guess whoever came up with that liked fractions because they could have written it any other way. But now we use a fraction, this rational exponent, where the numerator stands for the exponent on the base, or that radicand, and the denominator simply tells us what number goes outside the radical sign. So that's what a fraction exponent means. Okay? This just means like one of the most difficult ways we can write the number 5. And it just means that we're taking the square root of 25, which is 5. So when you see a number with a radical sign and with a fraction as an exponent, don't freak out. Just remind yourself, okay, this is some number that's being written in a different way that looks confusing, but it really is just a number written in a different way. And so now we can prove that exponents and roots are inverses, because since we have this fractional rational exponent that is the square root of something, if I want to undo or not have this rational exponent, I simply write it as a square root, because and then it's not there anymore. I mean, it means the same thing, but I'm not writing it. Just the same way as if I had 3 plus 5 equals 8, but I said, you know what? I don't like the adding sign. I don't like the addition sign. It just bothers me. I only like using subtraction. So I don't want that addition sign to be there. Then I could write 3 equals 8 minus 5. And then I would be like, I am so much happier now because I don't see an addition sign. So that's all we're doing, is showing that this is a new version of inverse operations. All right. Now, that was pretty dense. So, all right. So, when we have a problem that looks scary, as long as we just break it down into like little bitty steps, then it's not so scary. Now, there are really long problems, and that's kind of where you, like this year is really where you start having problems that take a long time. And there are many parts to them. But that's okay because, that's just part of life. Things that are more complicated take more time. But if you break everything down, it's not that difficult. The first thing you want to look for is, okay, can I figure out, is there an order of operations here? Can I do something first? Like, is there something for me to combine? Are there parentheses? Are there exponents? Is the distributive property there? So look for the order of operations. And sorry, this is so important. I won't say it drives me crazy, but it's so hard to follow someone's work. It's hard for students to follow their own work if you do like 4 or 5 things at a time. So every time you do something, that should have its own line. And I will tell you, if you are someone who kind of does their work all over the page, because this is what I see a lot. I'll see like, I don't know, 2 times 3x plus 4 equals 20. This is probably not going to work out nicely, but so I'll see like over here, I'll see like 2 times 3x equals 6x. And then I'll see like 8, like 2 times 4. And then I'll see like, so 6x plus 4 is 20. And then I'll see like in one step, I'll see like x equals 16 over 6. So like 2 steps in one. So this is how I see a lot of papers, like the work on paper organized. And it's like, no. That is going to make things really difficult. So one thing that's really good is called proofs. I mean, you don't typically do these a whole lot in pre-algebra, but you need it for algebra, geometry, and pretty much everything. And it really just makes things a lot easier. So I teach proofs with my pre-algebra. So this is what that means. I don't know, I did that. Oh, well, I'll do proofs in just a minute. Okay, so I'm going to pause the recording and I want you guys to kind of look at these questions. Hopefully you have some paper. If you don't have paper, go get paper. And I am going to give you some time to kind of walk through this. If you're working on it, you have a question, let me know. And then we'll keep going because I want to see, how many slides do I have? Oh, okay, that's it. Yep. All right. So that's not too bad. All right. So then I'm going to pause the recording so that you can ask me questions. Okay. So go ahead and pause the lesson now if you are watching and try these by yourself. And then you can start it back up again. I'm going to do them. I'm not going to work the entire thing out, like every single step, but I will talk about it. So I'll just do them one at a time. So if you want to try the first one and then watch the first answer and then try the second one and then watch the second answer. So they're not going to like all pop up at the same time. Okay. So go ahead and pause it and do at least the first one. This is the first one I'm going to do, by the way. Oops. Just kidding. And there we go. So this is going to be the first one I do. This is going to be the second one. And this is going to be the third one. Just so if you're going one at a time, that's the order I'm going in. Okay. So go ahead and pause it. And then when you're ready to check number 1, you can start it back up again. Okay. So the key words here are equivalent and exponential expression. So currently this is not an exponential form. This has a radical. So what I want to do is I don't want that radical there. And so then I ask myself, okay, what can be equivalent to a radical? Oh, well, I happen to know the rational exponent rule is Oh, that's supposed to be an M. There we go. Is that the radical sign becomes the fraction bar in a rational exponent. So I am going to use that rule to rewrite the radical sign. Now, the base is going to stay the same, so that's x. But now I'm going to put the radical sign as the fraction bar. And then I also know, hey, this is the rational exponent uses the other two pieces. Because here's something important. There are 4 pieces in this expression. There's the base, there's the exponent, there's the radical sign, and there's the index. So when I rewrite this, because there's nothing to simplify, I can't simplify anything. There's no like terms, there's no grouping symbols. So I need to make sure that I have the same number of things. So I want 4 things. Well, I have the base, that's 1. I have the fraction bar that used to be the radical sign, that's 2. Now I need to do something with the exponent and the index. Well, the rational exponent rule says that the exponent becomes the numerator of the rational exponent fraction, and the index becomes the denominator. So now I have an equivalent expression without the radical sign. I have the inverse. This is an inverse expression question. Just like if I were to say 3 plus 5 equals 8. Well, I just really don't like addition signs. I don't like them. They bother me. I don't want to use them. So instead, I'm going to write 3 equals 8 minus 5. That makes me feel much better. I don't have an addition sign anymore. I didn't change the value of what I had. I didn't change anything. I just rewrote it with the inverse operation. So this is all that means, is I have just rewritten this to not have a radical sign showing because I don't. All right, now you can pause it again if you haven't done the second question right here, and work it. But if you have, then you don't need to pause it because you can just keep listening and I will keep explaining. So this is exactly like the first problem, except in reverse. Here are the key words: equivalent and radical expression. Okay. This means I want to see a radical sign in my equivalent expression. So currently, I don't have a radical sign. Currently, my expression has 4 things. It has the base, which is t. It has the numerator, which is 5. It has the denominator, which is 8. And it has the fraction bar, which is a fraction bar. So I know that because, oh, well, I guess technically all of this is an exponent. I'm going to just group that together. Because I know the inverse operation of roots or radical signs is exponents. So because I have an exponent, the inverse is going to have a radical sign. Well, again, I happen to know the rule for the inverse operation. The rule is that the base stays the same. The fraction bar becomes the radical sign. The numerator becomes the exponent, and the denominator becomes the index. So I now have an equivalent expression. Means the same thing, just have it written with the inverse operation. So if you haven't done problem 3, go ahead and do problem 3. And if you have, or like pause it and do number 3. And if you have, then you can just keep listening because I'm going to explain it. Oh, excuse me. So sorry. Okay. This is identical to the previous one. Equivalent radical expression. So I have the base. I have my exponent, which has the numerator, the fraction bar, and the denominator. So I am simply going to apply the inverse operation. So the inverse operation is keeping the base the same. The fraction bar becomes the radical sign. The numerator becomes the exponent, and the denominator becomes the index. There you go. This gets easier with practice. Now, if you've done a lot of practice and you're still confused, I'm hoping this is helping. It's kind of the point of it. If it's not, you need to get in touch with me. Don't be like, well, she tried everything she could. And if I contact her, she's going to be like, why didn't you understand it? She's so mean. That is not what's going to happen. If you contact me and say, I need help with 3.01, I will say, did you watch the live lesson video? And you will say, I did. And I'll say, did you take notes for the whole module or for the whole lesson? And you'll say, I did. And I'll say, okay, well then why don't you come work with me and I'll work with you one-on-one. And then if that still doesn't help, because you'll be able to ask questions directly, then I will say, all right, no problem. Here are some additional resources that maybe have more practice, maybe have different explanations, lots of things. So never sit there and say, well, I guess I'm just never going to learn it. I guess I'm just, no, well, because there's always something that can help. Okay. All right. So let's clean this up. And now, when you look at this, you probably find it scary, perhaps. But you don't need to. You don't need to find it scary. All it is rewriting an expression. It says rewrite the expression. Okay. And keep in mind, if you're like, I don't even know that, I don't even know where to start on this. Just break down the question. Rewrite. Oops, probably want to turn my pen on here. Rewrite the expression in the form. And then it gives me the form. Rewrite in the form of this. So rewrite. All that means is I'm going to rearrange and simplify what's in there. Notice it doesn't say solve. There's nothing to solve. It doesn't say evaluate. Okay, they're not giving me values to put in. It just says rewrite. So I'm going to be applying different rules, inverse operations, to just rewrite this in a different form. Now, what form do they want? Well, they want this form. No, not a straight line. No, nope. Oh, undo. There we go. There we go. What form is that? That's exponential form. It's got a base and it's got an exponent. Now keep in mind that n can represent anything. It can represent a positive number. It can represent a negative number. It can represent a fraction. Okay, so just because it says n, that doesn't mean that it can only be one number. It could be a fraction. Okay? It could be positive, negative, fraction, whatever. So pause it, or I suppose you could have already paused it, but for sure pause the video, work out at least this problem, if not the next one, and then start it up. This one obviously is number 1, and this one's going to be number 2. All right, so there are different ways you can do this. There's order. I mean, there's only one answer, but there's different orders that you could take here. I am just going to write down the steps that I took. But again, that doesn't mean this is the only order to do things. So I'm going to be kind of quiet while I work through this so you can pay attention. And if you have questions, write them down. Write down, this is slide 10, I think. So slide 10, problem 1, and then write what your question is. And then send it to me or text it to me. Say, hey, I watched the live lesson, and on slide 10, that first problem, when you did this, I don't know why, or when I see this number now and I don't know where that came from, where did that come from? Ask me. Because those are that's the best way to get help, is to ask specific questions. So I'm not going to talk, but that doesn't mean that I'm gone, obviously, because my pencil's going to move. That's ugly. Seriously, come on. It's still not great, but whatever. Make some more space here. So yes, this was a long problem, but each step by itself wasn't a problem. And keep in mind, this is something a lot of students who come from a traditional school, like you go to your regular high school or middle school in a classroom. In virtual school, your notes are your tools. You can use your notes on assignments. You can use your notes on quizzes. You can use your notes on tests. Okay. That's what they're there for. Very different from a traditional classroom setting. So keep in mind, you don't have to memorize the exponent rules right now. If you use them enough, you'll know them, but you don't have to memorize them for the assignment or the module test or anything like that. You just have to take really good notes. If you just take really good notes and you have that list, that chart of the exponent rules, then you're fine. All right, now go ahead and pause it and do problem number 2. Or again, if you already did problem number 2, just keep watching and I will explain it. All right, so again, I am going to write and talk as little as possible, which I'm sure you're thankful for. So I am going to look at the question though. It says rewrite in the form k times y to the n. So I see this as multiplication with an exponent. And when I look at my problem, I see division with a root. So I know that this is going to require some inverse operations because I'm going from division and roots to multiplication and exponents. Okay, so I know that's going to be inverse operations. All right, so I'm going to do my little proof chart now. And again, as I'm working, if you have questions on something, write it down so that you could text it to me, email it to me, whatever. Oh, that is such a pretty line. Look at that. Oh, not so much there. Yeah. And give myself some more room here. So I just checked the form, and the 4 stands for is the replacement of k, and then the n is that exponent. So now I know. All right, so again, just break it down one step at a time, one thing at a time. What's the next thing you should do? Okay, what's the next thing you should do? Then make sure you go back to the question. Did you answer the question? So whenever you think you're done, say, okay, I think I'm done now. Go back to the question and look at it. Did I answer the question? Did I put it in the correct form? Okay, yes, great. Or, oh, whoops, I forgot about this thing. And then go from there. All right, so this is the end of the live lesson. And remember, if you have questions, please ask. And next week, I'm going to be going up to, I think, 3.06, and that's the sequences. I believe that's what I'm doing next week. That's also been something that a lot of people have been finding challenging. So I am going to work on that. And in the meantime, please make sure that you are working, that you're doing your assessments, your assignments. Take really good notes, please. And contact me for DBAs and any help that you need. Thank you so much for watching. I really appreciate it. Hopefully you'll get to come to a live lesson at some point if you are able to, and just say hi or ask questions or whatever. And yeah, I hope you have a great rest of your day, great rest of your week, and I will hear from you soon.